Okay, welcome back everyone. In this one, we're going to look at transformations of exponential functions. It's 7.2 and outcome R9. All right. So remember when I said everything you need to know from chapter 1, you need to know really well? Well, here it's going to make a resurgence, let's say. And all of the same things are going to apply, except for the fact that our parent equation looks a little different. So our parent equation is actually y equals c to the power of x, but now we're going to apply all of these transformations. So if you recall from the very first chapter, we had this here. We had y equals a times f of b bracket x minus c bracket plus d, and that kind of told the story of all of our transformations. The same thing's going to apply here. So I've taken the liberty to write this out so that you can review. Now this is a vertical stretch, and if a was less than 0, then that means we had to reflect over the x-axis. That's where all of the y values became negative. And here, c is our base. So that's just like our f of x base function that was there. B is our horizontal stretch. Now, same rules apply as the reciprocal thing, remember? The 1 over factor. And h here is our horizontal shift. And the horizontal shift was always opposite to the connecting sign. Our k is our vertical shift. So this tells us how many units up or down we're moving. All right, so let's have a look at our examples here. So the first one I'm going to look at f of x is equal to 2 to the power of x plus 1. Now I've taken the liberty to dot in the base 2 to the power of x so that we know what it looks like. And then we're going to do our shifts from there. Now this one only tells us to do a shift up 1 unit. So this is going to go up 1 unit right there. This is going to go up to here. This is going to move up 1 unit. And this is going to go off the graph to 2,5. All right. Now, I also have to make sure that I move my asymptote. Now, my asymptote is going to be here at y equals 1. All right, everything moves up. The whole thing moves up. Now, this graph, this exponential function right here, is never going to pass the y equals 1 mark. So the range for this guy actually ends up being y is greater than 1. All right, so this is our range. So our range changes. Okay, now let's have a look at this second one here. Pardon me. Now, our base is 3 to the power of x. So that means that we have a dot here at -1 and a third. 0 and 1, and 1 and 3. Now, the only thing we need to do here is, the first thing we need to do here is reflect over the x-axis. And that's because of this right here. Reflect over the x-axis. So I'm going to take all of these points and I'm just going to place them on their negative counterpart. Okay. And now that I've done that, I need to apply this next one here, which is shifting 1 unit to the left. So that's that way to the left. So this goes here. This goes here. And this goes here. And then I'm going to turn my page around because I can't really draw properly when it's... So I'm going to go through... Whoops, went through the wrong one, not paying attention. So I have to actually look at my paper when I'm drawing. Sometimes I'm looking at the screen and then drawing, which doesn't help me. Okay. All right. Okay, so here we go. This is what it looks like. I'm going to erase this mistake that I made right here. And that should look good. So just for safety, let's just write in the points. -1, -1. Okay, a couple of points there just for giggles. And let's put in our y, our asymptote here. Okay. Now, for this one down here, where it says g of x is equal to 4 to the power of -x equals, -1. Here are my base points. Now, this negative on this exponent forces me to reflect over the y-axis. So that means that I'm going to take this point and it's going to reflect and it's go over the y-axis. So it's going to go right here. This point stays as is. And this point is going to reflect over the y-axis. So it's right here. Okay. Now now that I've done that, I'm going to move everything down 1 unit. So this point ends up going down here. I'll make it look a little different so that I can, this point goes down 1 to right here. And this point goes down 1, so it's right here. All right. And then my asymptote also moves down 1. So y is -1. And my graph is never going to go past that. So let's draw in my curve. Hopefully it doesn't make you too dizzy when I'm moving these papers around. All right. So now hopefully you can kind of see what I've gone through. So this is at 0, 0 now. This point moves down. And this point is at -1, 3. Up there. Okay. Make sure it's nice, smooth curve. This kind of looks a little... Okay, now here for this next one, this last one, I've taken the liberty just to show you a little table of values just so you can verify your numbers. Now here we have a 1/2 in the exponent. So this means that I'm going to have a horizontal stretch factor of 2. So I'm going to multiply all of my x values by 2. So this is my base. And now this x value is -1, but it's going to end up being -2. So it ends up going right here. This x value is 0. So that gets multiplied by 2 and that stays at 0. And this has an x value of 1 and it's going to get multiplied by 2. So it's going to end up here. So you can see that it's been stretched by 2. So it's wider than the original. And nothing else changes. So my y equals 0 is still my asymptote. Now on the next page, I've got a example that combines all 4 of them together. So why don't you give this one a try, hit pause and see if it ends up looking like what mine does. All right, so if you've hit pause, you've already got this done. If not, then you're just going to go along with me. And, well, either way, you're going to check your answers. Okay, so I've taken the liberty to write down all the transformations that are going to happen. My base is 3 to the power of x. That's at my a, okay? And as I go, I'm going to label them B, C, and D. Then I'm going to multiply all my y values by 2. So here, my y value, this is 1/3, and it's going to end up being 2/3. So I'm going to call that B. This y value is 1. I'm going to make it a 2 and call that B. And then this is a 3, so it ends up being a 6, which is right up here, and we'll call that B. So now I've got my 3 B points that I'm going to do the next thing to. I'm going to move everything right 1 unit. So right is this way. So my C is going to end up right here. This is going to go 1 right, which is C. And remember to move it from the B to the C, which is going to be 1 unit to the right. Now I'm going to work from the C's to go down 4 units. And I'm going to label those as D. Okay, I'm going to work with the whole numbers first because those are just easier to do. 1, 2, 3, 4. So this is my D. And then 1, 2, 3, 4. That's my D. Then here, 1. Whoa, I didn't move anywhere. 1, 2, 3, 4. And this is my D. So I did this one last because it's not on a whole number, it's on a fraction. So you have to make sure you're moving the appropriate number. And now my asymptote also moves down 4. So that means my asymptote is going to be down here at y equals -4. All right, so now connect these with a nice smooth curve. And that's, put arrowheads on the ends, make it look pretty. Okay, and there you have it, folks. So this point right here is 2, 2 that I end off with. This point right here is 1, -2. Beauty. All right, so now the equation of the asymptote, and I've already written that up there. It's y equals -4. Here, I want you to just kind of note, we'll go over it again. Here, note the 2 is the constant and doubles all the y values. So this 2 right here, and this is written in the f of x form as opposed to the base form, right? So if you look at how we wrote the equation just at the top of the page, this is the function notation version of it. So you've got one shift right 1 and you're down 4. Okay, so this would also be the equation of the function. All right, and finally, homework. This is for you guys. Make sure you guys practice your questions, practice your homework so that it gets stuck in your brains, and make sure you ask me questions if you have any. All right, toodles.